Hello, everyone, and welcome once again to today's webinar titled Kubernetes and Open Source Container Engines. My name is Michelle. I'm here to produce the webinar, and we have Tim Sarowitz here, lead instructor for Linux Foundation, who will host today's discussion where he will uncover which open source container options are available, discover the pros and cons of these options, and inform us about the current state of open source containers. That's a lot to cover, but let me start with the webinar functionalities. During the webinar, everyone's phone will be muted. So if you have questions, please enter them in the Q&A box at the bottom of your screen. There will be a dedicated question and answer session at the end of the lecture. If you enjoy the presentation today, and if you're interested in learning more about training anywhere with our interactive virtual platform called IMVP, please visit our website or contact us. Today's webinar is being recorded and a copy will be sent to each and every one of you by the end of the week. And finally, stay tuned till the end of the presentation where we will share a promo code that'll save you $250 on public training. All right then, let's get started. You can take it away, Tim.
Thanks, Michelle. As Michelle mentioned, my name is Tim Sarowitz, and I'm a trainer for the Linux Foundation. And we're going to be talking about open source container engines. So since we've already done a little bit of the intro what it's about, let's jump right in. The first question that a lot of you may be asking yourself is, why should I care? Why is this important to me? And there's a few reasons, one of which might be kind of the preeminent reason. First off, open source software, as the slide says, need I say more? It's open source. As we all know, it is the best option. Of course, that comes from somebody who is an open source evangelist. So I might have my own biases there, but I do think that there's a lot of reasons to use open source. One of the big reasons that you should consider looking at open source engines is actually a proprietary engine, specifically Docker. Docker is a very powerful and very good container engine and management tool. So I'm in no way saying that Docker is anything but outstanding, which it is. And there's a reason that Docker has become the industry standard for managing containers. A product I work with an awful lot is Kubernetes, which has become very popular in the open source world. And Kubernetes leverages Docker as the container engine in many, if not most, of the distributions. So Docker is a great tool. There is no denying that. With saying that, there is perhaps an asterisk to be aware of. Normally in production environments, I always encourage people to use the product that a lot of other people in similar circumstances are using. It's something that I call the well-worn path. So the kind of humorous way I put it is, if you have to run through a minefield, you could get a map, but you still don't know really where you're going. On the other hand, if there's a well-worn path through that minefield that other people have found, it's probably a good idea to follow it. Not in every case, but if I have to choose, I'm going to follow the guy in front of me. And so typically if somebody asks and says, hey, I'd like to use Docker, it makes sense. It's the standard. It has a very powerful tool set. Why not? Well, something to be aware of is that that well-worn path just had a major detour put in. One of the largest distributors of Linux is Red Hat. Red Hat, about 2 years ago, announced, at least internally, that they were diverging from Docker. There was some harsh language and so forth. And then with RHEL 8 and Rev 8, so their virtualization, atomic host, and everything in 8, they actually did what they said they were going to do, which is they will not support Docker. Now, what that means is, it's not that they don't encourage it and they want to sell their own product. They're actually saying that if you use Docker, we will not support you. Since Red Hat is, give or take 70–80% of the mid-range Linux market in the US at least, that's pretty big. That's a big statement. So what that means is that while Docker is a very good tool, one of the major players is choosing to go a different direction and effectively forcing their customers to go with them. In the past, everyone would end up following kind of where Red Hat was going. It's not a rule or anything, but there's that trend. So with that in mind, it's a good idea to be aware of some of the other options that you have, and that it's possible that if you want to continue getting support from somebody like Red Hat, and which of course now owned by IBM, that you may not be able to use Docker. That if you had an issue, they would say, well, try it with one of the other engines and give us a call, and then we'll help you. So it's definitely worth knowing that some kind of big changes have happened, and it's really not about the strength of the tool. Docker, the tool, is fine. It was really, from what Red Hat said, that Docker would change the code without a lot of warning, and that did not allow Red Hat or other people to change their software to match it. So they were always behind and being blamed for issues. They tried working on it, didn't work out, became an issue, and that's why Red Hat moved. So it's really not about the strength of the tool. It's that there were too many changes, and that as partners, they felt they weren't being told about them. So if we're moving, if the path has changed, the well-worn path, other people are running down a different path, then what are we going to look at? Where are we going? And that's really what we're going to talk about. Are one of my options, some of which I would suggest, and I'll tell you why, and then some that you may hear about but may not be a well-worn path. One of the reasons that open source software is good, and I won't spend too much time getting off on this, but is the flexibility and the open standards behind it. That we all then know what's going on inside of the engine. That we're not just having a binary that we're unsure necessarily what it's doing. All of us can see it. And it is able to be changed. So if there's a feature that you really need, nothing stops you from doing it. Also, the community can be very responsive. And again, this is why getting together in that well-worn path may be a good idea. Other people having the same issues you do. So if there's a bug, entirely possible, there's a bug or undocumented feature, as it's sometimes called, that the responsiveness is based off of the community need. So instead of a single vendor who making an edit or a change may or may not be in their roadmap, you don't have to hope that their roadmap matches your roadmap. That we need a feature, we need to fix a bug, great, let's just do that and contribute back to the community. So if we're moving, we may as well move to something that is flexible and open and as responsive as our involvement is with the community. So since we're talking about a container engine, let us talk a little bit about what a container is, and that might help a little bit of the understanding as well. When it comes down to it, a container is a process. So, and see, it's simple. We can all go home now. So there's a little bit more to it than it's just a process, but a lot of times there's a misunderstanding that it's something perhaps more complex, and there is definitely complexity possible. But when it comes down to it, the command like PS, process status, you could see the container running. We have that process that has a whole bunch of stuff attached to it, and it's often based on what's called an image. That image is distinct software, so it's what you'd like to run. There's a few different ways of building these images. Oftentimes, they're also done as a layer. There's lots of options, and perhaps this is a downside of open source, is there's lots of options. And when that one path is no longer the path everybody's on, now there's 10 new paths, and they're slightly less well-traveled, and you have to choose among them. But one of the ways that containers are made is through another union file system where you layer different images, and that allows you to edit them. So you have a base layer, and then almost like the old school transparency where you'd write on it with like a watercolor pen and it would shine on the wall behind you. By stacking these transparencies, you can end up with a configuration. You can then slide out any one of those sections and change the overall end result of that configuration. When it comes down to it, we want to run a process. That process is going to do something. Now, single process to a full VM. So that's one of the advantages to containerization instead of running a virtual machine. We don't need to have the overhead of a full system. We don't need to have the overhead of a cron daemon running and cups printer and so forth and so on, that a container could be as small as a single process. It could be as large as a full VM. So with containerization, one of the reasons that it's very attractive to people is the microservice. I'm going to take my old monolithic applications and I'm going to make them small and decoupled and as apart from one another so I can change them. Think about a model airplane instead of a stack of Legos. The model airplane looks like the cover of the box it came in. That's what it is. So if I want to change a part, it's not so easy. I'm better off getting a new model airplane. Whereas if I have a whole stack of Legos, if I decide I'd like the fourth Lego up in this pile to be blue instead of red, I can change it out pretty quickly. So having lots of small decoupled microservices allows a lot of flexibility, and you can then do stuff like CI/CD or continuous development, rolling stuff out if it doesn't work, very easily rolling it back, and you're not doing that monolithic whole of that model airplane that has to look like the cover of the box it came in, otherwise it doesn't work at all. So our containers then could be a full VM, although there's a lot of reason not to do that, but more likely you're going to probably want to consider having the smallest possible container and then just lots and lots of them. That's all based off of some image of software, some configuration files that are brought together. Containers, in addition to being a process running, also take advantage of a namespace. A namespace is a kernel feature that allows you to have distinct copies of the same information. So they're distinct, meaning they don't rely on one another, and they can be truly isolated. So for example, you could have multiple containers with the same IP address on the same host. So it's like, well, same IP, same host, how does it tell the difference? Well, that's where we need something to help us decide what namespace something is in. But the advantage of this is, as I mentioned, these microservices, now I can have 50 web servers running on that single node, and each one of them can have the same IP address. I wouldn't suggest that, but it's an option if you have the ability to divide up the namespace that they exist in. Another reason that containers are great is because of resource control. So a C group, again, another kernel feature where now we can start allocating or limiting how much memory or CPU that process has. So I have very granular controls of it. I have lots of these microservices, things that are small as possible and decoupled from one another, to which I isolate them so that I could duplicate or edit different IP addresses and network stacks and file systems, configurations, all these different many possible things that could be changed and run simultaneously on a single instance of Linux. That sounds simple when you say it, but there's an awful lot of complexity that goes into assigning of those resources, the IPCs and the file systems and the network stacks and the isolation and so forth. So to do all of that, we have a container engine. So the engine, the job of an engine is to help us manage those resources. So something as basic as who's responsible for attaching storage and eventually removing the storage when we're done with it, or the IP address, or just running the process, the container, in the first place. So in this space, you should probably be aware that there's a lot of terminology, and sometimes that terminology may be misused, and hopefully I don't do the same. But I want to forewarn you that I've noticed when doing research and looking at documentation, I'll often hear the same term, sometimes in the same document, and they don't quite line up. Because of the open source nature and because a lot of people working independently, this is one of the downsides compared to a single vendor product. With a single vendor product, there's some vice president in charge who says this is the way it's going to be and decides all those things. whereas in the open source community, people can use a term or an idea, and there's no real unilateral decision, good idea, bad idea. Eventually, the community may say, hey, we'd rather do it this way, but you may see some of these terms used in a different manner. So the whole idea of a container engine is something that helps manage that potentially complex container environment that will help us in attaching storage and network and resources, also the running of that process itself with the C groups and whatever runtime they may need to be in. Even from the very beginning, so I send a call of some sort to the container engine, and I said I'd like to have a new container running. So for example, Docker run. Okay, well then it, meaning Docker, will download the image if necessary and unpack that image on my behalf, look at the config files, interpret them, and pass them to my instance on my behalf, such that the running container has the resources it needs and is constrained the way that it needs to be constrained. When it comes down to it, it's still just a process running. So the kernel is actually running the process. The container engine is helping manage all of the many things that go together to get that process to run. But commands like nice, top, ps, those are all able to look at those containers running. It's a kernel type process, or it's a process run by the kernel, I should say, when it really comes down to it. So you can manage it with NUMA commands or with other performance commands, perf, ftrace, and so forth, in the same way as any other process. At the bottom, we see that I have some examples here. The Kube API server going to Docker engine, going to containerd to runc to Linux kernel. And underneath that, we see the primary replacement, or the new path, instead of Docker, called CRI-O. And we'll learn more about that in a second, where we see Kube API server going to CRI-O to runc to the Linux kernel. And we can see there's some slight changes. One point I'd like to make is, those are just 4 examples. There's actually at least 4 or 5 other paths and other libraries and other things that you might see in this path. And again, this gets back to that well-worn path concept, but also open source. So in the open source community, people say, well, you know what, I think it should be done this way. So these are not an exhaustive list of the process and the flow from, in this case, Kubernetes sending a message to the engine and so forth. It's just 2 more common ones that you might encounter. And since they're more common, and it's also where Red Hat's kind of going, I wanted to show you an overview, but it's not exhaustive. There's other flavors, options, and any one of those things you could probably swap out. But it shows you that, in this case, if it was Kubernetes, as I mentioned, very popular, that would normally be telling Docker, sending it some sort of API call, and then Docker would communicate to containerd, and then runc to the kernel. Now CRI-O is acting and is a drop-in replacement then for that, that Docker engine and containerd. That's the way that engine was built. So another way of looking at it, so because Kubernetes is very popular right now, I have this slide so you can kind of see, where does this really happen? All of the nodes in Kubernetes are running some sort of engine. And in this case, we see that, so even the master nodes would have Docker or CRI-O running on them. In this case, we see that the various calls are going to the API server. It communicates with other agents in this environment, and then communicates out to kubelet on the worker nodes. So we have 3 worker nodes on the right-hand side of the graphic. And then kubelet talks to the engine on the worker node, any node actually, because even the master node, the API server, the scheduler, and the manager, all of those agents run as pods in the most common flavors of Kubernetes. I use this slide also so that because the overall orchestration software that is Kubernetes doesn't really talk directly to the engine, I wrote Docker/CRI-O. You can, when you set up a worker, you get to choose. You can say it is the difference is this engine or that. The overall cluster doesn't actually care, it doesn't know. It says, hey, you run that pod, as it's called, for me. Then the pod is filled with containers. So you run that for me, locally. So your environment then could potentially have a mix. You wouldn't be supported, but you could have different engines on different worker nodes because Kubernetes doesn't care. And CRI-O, which we'll get into in a little bit more detail in a sec, was also written by Red Hat to be a drop-in replacement so that you didn't have to think about it. It's a slightly different tool set, but that everything else around it works easily. That's the goal. Some of the things that help with this, this environment is, as I mentioned, open source community is having what's called CNI. And CNI is a container network, and what we're talking about here are open standards. So this is still in, I wouldn't say it's in development, it's being used, but I would say it's not 100% mature. Sort of like your typical 17-year-old. They're an adult, they can do a lot of stuff on their own, but they might need some help. They're not quite 100% mature. Maybe 18 or 19-year-old might be a better example. Still need some help with laundry and gas money. But the idea is that this is becoming an open standard such that just as Kubernetes didn't care what the local engine is, it's not really interacting with it directly, with CNI network as an open standard and library calls, that it really doesn't matter if your host, for example, with Kubernetes, you could have a Ubuntu system and a Red Hat system and a Windows server all running as workers for that same Kubernetes cluster. Because we shouldn't care what the local OS is doing. We should have some sort of open and unique, independent way of communicating with it. And that's what CNI networking does. There's a URL there, github.com container networking, that you can see about that, not only just providing resources, but when the container is no longer running, how do I clean up afterwards? Another big part of this is OCI, or the Open Container Initiative. The Open Container Initiative declared some of the things that need to go into a container. It's to provide a runtime spec for how a container should run and how the image should be built as well. Again, the point of it being a common standard so that a containerized process and its image could be run in many different environments. So it's not tied. It's not tied to a proprietary or, for that matter, open engine. So what goes into the manifest, how the file system is serialized or brought together and otherwise kept track of, and the necessary config files that go with a image. This has been around for a while, and Docker actually was very big in helping create the Open Container Initiative. So again, kudos to them for doing that. The unfortunate part, as I mentioned, it's that maturity thing where it's like a 19-year-old, it's an incomplete standard. Who is really running things? Who will make changes? Who's responsible? And so forth. And if, the wonderful place that Twitter is, if you dig into it, there's a lot of back and forth about that. So it's the containers are following open container protocols, but it is one of the areas to be aware of that it's not necessarily settled down in what these various things should do and how they interact. That is changing quite a bit, again, with Red Hat changing to CRI-O. They're also doing some other tools and standards that, as I mentioned, the open source community is following that well-worn path. And I think a lot of the OCI standards will be further solidified as it just becomes obvious that it's the best way to do something. So I mentioned Docker again. Great tool. A little bit ago, Docker actually spun off their own code. Again, Docker's a great tool, so I don't want anybody to misunderstand about that. It is really more about what are they doing? What's the management? Where are they going? So Moby is, and this is a quote from their Docker website, an open framework created by Docker to assemble specialized container systems without reinventing the wheel. Okay, because it was based off of Docker, they said, oh, well, we're just going to give you this subset of it. They had 3 different products. They didn't explain really well what the differences were and why we should care about Moby, if Moby was the same thing, if they were giving up on developing their other 2 and how that is. So that confusion caused a lot of folks to say, I don't even know what I'm, like, which tool should I go with? What's proprietary? If I write code, who gets it? Where does it go? And what happened was, what the community support that was going with that became, basically, it went elsewhere. That people were like, it seems a little bit mess, I'll check back later. Strong tool set, so it's nothing with the technology. It's just a matter of how that rollout was handled and miscommunications between everybody, really. But so again, it's not that there's anything wrong with it. It's just the rollout kind of fell on its face, and people said, okay, where else? Combine that with Red Hat moving to a different tool, and that's why if you look at the commits and so forth, it really dropped off a cliff. Rkt, RKT. Rkt was an early entry into the area. From the beginning, had more of a security focus. So the engineers and the documentation always kind of had that in mind, that they're like, and this is why you should use it, because we're more secure. The main developer, so Google gave some money to CoreOS. CoreOS was really pushing Rkt, was doing a great job. CoreOS being a group, and CoreOS.com is still around, but it will redirect you now to Red Hat. So Red Hat purchased that organization, and when that happened, all the work that was being done on Rkt, which again was a very strong engine, and as I mentioned, a pod native container engine. So it was really kind of a purpose-built tool, learning from what other people had done, taking the best of it and making a tool. And what happened was, it wasn't anything with the product itself. It didn't get huge support. There wasn't a really well-worn path in the community, but it was being used, definitely. When Red Hat bought them, then it will, when Red Hat bought them, the changes that happened was the developers were basically reassigned. So all the developers that were working on Rkt were now working on CRI-O. The project moved to CNCF. CNCF is the same organization that owns the copyright to Kubernetes and Prometheus and all those other ones. So CNCF, the Cloud Native Compute Foundation, got this project, and now, sadly, has the dubious honor of being the first project that was archived. Okay. So the and why? Because as soon as all the paid developers of CoreOS went to Red Hat, they stopped working. That's their job changed. They're not working on Rkt anymore. And so the CNCF actually had to figure out, okay, what do we do if nobody's working on it? It's been several months and not one commit has taken place. So it's archived. Now, what that means is that the code's still there. You could actually get it and bring it back to life and start writing code for it. So that's the good news, is that you can take advantage of it, but you'd be the only one. So it's not gone. It's just been mothballed, so to speak. It's been archived, and a lot of those features and tools, kind of the best of it, I think you're going to see more and more of it show up in CRI-O. Because the because the engineers are now working on CRI-O. So distinct in how the particular the mechanisms worked, distinct in some of the organization of management, but Rkt, for the most part, all the really cool parts you're going to see in CRI-O soon. I know that somebody had asked about the shift from Docker to CRI-O for the exam, and the short answer is it will eventually move to CRI-O. At the moment, it is still on Docker. If you saw the slide from a while ago where I showed you that Docker is out there on your node and it's not talked to directly, the advantage to it is Kubernetes doesn't change. It's only on the kind of the end worker, or the master, but on the end worker, that a call is made to the local engine, whatever that engine may be. So it will shift over. I don't think it's going to be that soon. In other words, not in the next 3 to 6 months, but it's definitely going to happen. But I can't tell you when, because Docker works. There's nothing wrong with Docker. It's just a matter of going forward, how is it going to be? So Rocket was great, is mothballed or archived. Maybe comes back, but at the moment, I haven't looked in a couple weeks now, but I think it's been 4 months and there were no commits anywhere to it. But again, I don't keep track of it now that it's been archived. CRI-O. Of all of the different projects that you might want to look at, CRI-O is where I would really focus my attention. This is a purpose-built engine, container runtime interface, so CRI, OCI compliance, so CRI-O. Any OCI compliant image can be run by CRI-O. Any runtime. We saw that flow to containerd and runc and so forth. It was written to have that modularity that you can very easily change to what works best for you, or if the well-worn path goes a particular direction. Runc and Kata or Kacha are currently supported, but others might work. And again, it's an open source project. So if there were a different end lower runtime that you wanted to use, you can definitely do that. Any compliant registry. Now, one of the reasons that Docker is so powerful is Docker Hub. I can get any image I want from any vendor and an easy way of installing it from Docker Hub. Well, any compliant registry can be used by CRI-O. And at the moment, at least, Docker Hub could be one of those, or your own. And there are other organizations that are making and building and working with registries to give us a independent registry that's not one vendor. It's not Docker Hub. It's something. I'm going to look at a tool called Scopio coming up that will help with this. But the idea, again, is that if we're going to move from a single vendor to open source, let's have all the other related parts be open as well. It is a CNCF project and strong Red Hat support. I should probably have bolded strong. Red Hat has said this is where we choose to go. Now, Red Hat may have their own engines and maybe doing their other stuff, but if nothing else, but to make it obvious that they were leaving Docker behind, they said, we're done with Docker, it is CRI-O for us. So they have put their full support behind the CRI-O engine. One of the differences is that instead of a single, very large, kind of bloated Docker binary that is managing all of them, it's a very lightweight. There's multiple lightweight processes called conmon, as in container monitor. So if I had 10 containers running in an instance, I'd have 10 conmon processes, one per, but very, very lightweight. So that, and this is one of the big changes between Docker, is now I have more dedicated, more granular, more independent control, and it's modular, as I mentioned. It uses CNI for networking. Some of the plugins that you choose may enable that or not. You might have to go out of your way to actually enable that, but that's one of those choices. And does run runc for containers. So if you go to CRI-O.org, you can see, and it's pretty much all the steps are Red Hat related or CentOS, although there are some ways of getting it to work for Ubuntu, for example. At the moment, it's a little bit of extra hassle. There's about 30 extra things you have to do, commands to run, to get it to run on Ubuntu. They're not hard. You just have to kind of go down the list and do X, Y, and Z. Very soon, though, it's every month it's getting better and better and better. So soon it will be just an install choice. Do you want this one or that one? And that's all you'll need to do. Containerd, which we saw in the path before, that is not really an engine. It's a runtime. So remember that we talked about what an engine does, is that not only does it run the process, but it also helps manage the environment, the networking and the images and the various other tools. So a runtime is part of the flow from when I ask for a container to it running, but it's not really the engine part of it. It's a subset of that. There's a lot of different tools that will talk to Containerd. So again, well-worn path. A lot of people are using it. Docker does, Swarm, Mesosphere. Kubernetes has a CRI-Containerd for a tool for working with it. So there's no direct CRI implementation, but there is, again, a module, basically, that you can interact with and put in there for gaining access to it. So it is a traditional runtime and will probably be with us for a while, but you probably don't need it as much, especially going forward, as a lot of those features are brought into different tools and done in a different way. Another option, slightly less well-known perhaps, is Frakti. This is a hypervisor-based container runtime. So it like, for example, having a lightweight hypervisor, Atomic, or with VMware, you have a very lightweight, powerful, sleek hypervisor running things. Well, that's the idea behind Frakti, is that it's this very kind of purpose-built hypervisor that's running those containers, and it with a very limited view. It uses something called runv. Because we're running it in kind of an environment almost VM-like, it gives us a lot of flexibility. The independent kernel, as they say, bring your own kernel. And another advantage of this is that because it's presenting them or running them in almost a VM-like manner as a hypervisor and deploying each one, you could have mixed runtimes. So you could have runv running and Docker. So if you're in a production environment and you're thinking, okay, looks like Docker's not going to be the Linux engine anymore, let's start running runv. And we'll keep Docker over here, and we'll runv there, and we'll compare and contrast. Which one's better for us? Is it worth using? Do we go or do we stay? What do we do? It gives you those options to work with. Railcar is another one. Railcar, again, you may not have heard about it very much. Similar to runc, but it was written in Rust, the Rust language, and again with security concepts in mind. Does not implement all of it, though. So it was written there, and it's similar, but not fully implemented. Similar to how CRI-O works, every container gets an init process. It was created by Oracle. Strangely enough, Oracle has MySQL and open source and so forth in its past, so nobody has gone to help. So Railcar appears to not be updated. I noticed there were some updates all by Oracle employees, but nothing minor. The community has not gotten behind Railcar from anything I've seen. CRUN, another potential tool, an OCI runtime. It's actually, instead of Go based, it's based off of C, so there could be some performance increases there. Lots of features are listed, but as the slide says, there's a lack of clarity on maintenance and support. So are there enough people working with it that I can trust my enterprise to work with it? It's not bad. It looks to be promising, but the community hasn't really gotten behind it quite yet. gvisor, a sandbox-based containerization tool. So it's kind of taking some of the Linux concepts to get there, pioneered by Google, and thus Google Visor. I think Linux by way of Linux. So they're trying to use some good concepts of process management, using something called runc as a boundary then between the application and the kernel space. It runs in the normal user space as a process, But again, it's just another effort. So Google got behind a couple different things to see what other engines other than Docker that they could interact with. And it's just another project that is getting some attention, mostly by Google people. I wouldn't say that it's become mainstream, but it's something to definitely keep an eye on. It might solve or answer some of the things that your issues you may have in your production environment. Runc, we've mentioned this, and again, it's not an engine. It's part of the process of running a process or a container, but the C is the running of the C container. So that's how do I get it to actually run? Again, another generous thing by Docker that it created what it said was all the plumbing. It was a kind of a mess to manage, and this is from their release, that it was just becoming kind of a messy, huge project to manage, and they said, let's just create a universal container runtime that everybody can agree to do it, and we're all on the same page, and the community can help us help them. So from that, Google, IBM, I have IBM twice in that list, but Red Hat, I think is what it was, and somehow Red Hat got changed to IBM. But the Open Container Initiative, opencontainers.org, was spun off from that, saying, great, thank you, Docker, for providing your plumbing. Let's all work together in an open community such that we're all on the same page. And again, it's the default for Docker and Kubernetes. There's a GitHub link there that you can read more on it. But it's really intended as that last step before talking to the kernel itself. So it's the running of the container, not necessarily the management of resources and other values that go along with it. Kata, or I've heard some people say Kacha, I don't know. I think it's just Kata. So if I'm misunderstanding it, I apologize. But this was pioneered or pushed a lot by Intel. It's actually an open source tool. It's under the OpenStack Foundation, so that's a different organization. So CRI-O is under CNCF. Kata is under OpenStack. There's a URL there for Kata Containers that you can look at. It's, again, mature. So if overall the various engines we're talking about are 19-year-olds, I would say Kata is like a 16-year-old. So definitely can drive and have a job and so forth and pay taxes, but it still has some more limitations that it's not 100% there yet. It does support multiple hypervisors. The tool set and listed what it should do is quite impressive. So I can see this as definitely being another option instead of CRI-O. If I had to say something else, my primary one I would look at would be Kata if it continues to mature the way it has been. We're not quite there yet, but it's something I would keep an eye on as a possibility. Other tools out there. So the nice thing is that a couple years back when Red Hat, they made an internal announcement saying they were, they said some stuff, but we're done with Docker about 2 years ago. A lot of people, the word leaked out, and a lot of people started building their own tool sets. LXC actually had been around before that. Canonical is the steward of it. One of the reasons that LXC, I think, did not make it out farther, it's a powerful tool set, but they really wrote it specifically for Ubuntu. So if you're not running Debian, there's not real use of it. So I think a lot of people said, well, yeah, but we have all these CentOS or Fedora or Red Hat boxes or SUSE boxes. We'd like it, but it'd be great if we had one tool for everything. So LXC and a lot of the tools that Canonical is putting out, they're very strong and durable. They unfortunately tend to be inwardly focused, just on Ubuntu or Debian. So it's one of the things to kind of keep in mind that are worth knowing about, as the case might be. Firecracker, that's something that Amazon has been pushing. Intel support, AMD and ARM on the way. But because, of course, Amazon is a huge IT environment, containers and VMs are very important to their business model. they're saying, well, yeah, we don't want to be too much there, too much there. What's in the middle? And that's what Firecracker's meant to do, is kind of run in the middle of functionality, independence, manageability between a container and a full VM. Nabla and others, as I mentioned, the open source community has gotten quite large with the other things that are available to you. Now, speaking of other things, tools to use. I mentioned CRI-O, and CRI-O is a very powerful tool, but it's modular. It's meant not to be what you had with Docker, which became a very big, very kind of bloated, try to do everything tool. So CRI-O is just going to be for running containers. There's other tools that you would use for each individual function. So Podman is a tool that would replace Docker run. So if I just want to run a container right now, see what's going on, I would use Podman. If I want to build my own image, I would have Builda, as in if you were in Boston and it was wicked cold out. He's a Builda. So Podman and Builda are two brand new, so it's podman.io, I believe, and builda.io. Those are two relatively new websites that Red Hat built. So when they cut from Docker and said, we're done with you, they started throwing money into all these projects to replace all the functionality. Scopio is about images. I mentioned how Docker Hub is a very powerful thing. Well, Scopio is meant to go to whatever the many repositories are, pull them down, and so forth. If you go to this GitHub site, github.com/containers, you'll see the main pages and the GitHub pages for Podman and Builda and Scopio. Most people, especially, for example, in the Kubernetes environment, Podman would be a handy way of testing that your container is running. Builda for building your own images. So instead of Docker build, Docker run, we have Podman and Builda. Instead of Docker images, we have Scopio. Those three will handle a large portion of the tasks one would have typically needed to do with Docker commands. And there's more. There's 8 or 10, and of course the list is growing. If there's a functionality that Docker had or others have, that you'll probably find it listed here in containers. So definitely check out those projects. There's other runtimes in the world. So I want to make you aware that the joy of open source and runtimes and the engines and the tools that use them, there's a lot of activity going on. So the kind of the grasp of Docker doing everything, because it was a good tool, has been weakened. Other people are trying to pick up the slack. We see Kubernetes. That is, at the moment, the leading orchestration tool for containers. OpenShift, very powerful tool with lots of additional features added on top of Kubernetes. Cloud Foundry is another way, just kind of slightly different mechanisms to do so. Apache Mesos has been around for a long time. They were let into the secret by Google before Kubernetes was released. Amazon ECS has and other tools for managing containers. Singularity is a platform for HPC primarily, but they also do AI and EPC. And OpenSVC is for kind of handling older legacy stacks that are along the way. So with that in mind, you might be asking yourself, okay, what's next? The change is what's next. So the only thing that will be constant is change moving forward. I would encourage you to follow the well-worn path. Join and contribute, though. So don't just do what other people are doing. If there's a feature you need, maybe in one of the other tools, definitely follow that. If it was me, I would spend some serious time looking at CRI-O. It's going to be the Kubernetes default soon. Not tomorrow, 6 months, a year. It's going to be CRI-O. Could be Kata, though. I would hope, I'm not a developer, but I would hope that you could actually make a choice. When you're installing, it would be which engine are you using on your various nodes. And on each node, you could say, this guy's Kata, this guy is CRI-O, and maybe Frakti. But the flexibility and other options are definitely where we're going. Open everything, I really think, is the future of the production environment. And so again, please do join and contribute. You're helping yourself as well as others, and the the follow back and the benefit is really quite large. Thank you very much. Here's a page on some more Exit Certified information.
Thank you so much, Tim. I just want to speak again on the fact that we've recorded this session, and we're going to send a copy of the presentation to each and every one of you. And as promised, let's talk about promos. So I mentioned that you can save $250 on your public training when you use the promo code SNOWBALL and register by January 31st. I'm going to post that in the chat for everyone now, as well as a few links to some of our Kubernetes classes. Tim, there's a few questions in the Q&A, so I'll pass the mic back over to you.
Okay, thank you. Let's see here. I see one here. I'm new to containers. Can a piece of code like an enterprise Java application, so REST web service, already running on WebSphere or JBoss, be containerized? Or do containers need programs created with particular software development languages? Is it a recommended approach, or is it preferred to create new apps that are natively prepared to run in a container environment? Okay, good question. Long answer. It would probably take me an hour to get into the depth of it. Let me start with the shorter version of it. You're better off with the smallest thing possible, the most microservice you can get. So when I hear WebSphere, in my head, I'm thinking, wow, that's going to be huge. Here's your 15 meg, 15 gig thing. So typically, I would say most places I've been, when it really comes down to it, you can containerize your large application, and you have nothing but frustration afterwards. You're far better writing your applications with a decoupled, transient microservice environment. So decoupled meaning don't hard code anything. It's not about performance in that sense. We're spreading it across lots and lots of cheap servers. Decoupled, nothing's tied together. Transient, I could kill any process at any time and I need it to respawn. That will be the hard part of the rewrite. Most monolithic and legacy applications like you're talking about are not transient, they are not decoupled, and they're not a microservice. So while you could do it, I would definitely encourage you to, going forward, start writing towards microservices instead. And I think that's the other two are just, commands that during practical. At the moment, it's still Docker, but at some point it'll be Podman, Builda, Scopio, and other tools like that. But for the immediate future, or the next at least 6 months, I'm the guy who works with it a lot, at least 6 months, if not longer, before any of those changes are made. And you'll most likely hear about it well in advance, like three to 6 months in advance. I think I answered it all. If not, any other questions? My pleasure.
All right, well, if there are no other questions, thank you again one more time. Hope to see you again soon. Enjoy the rest of your day.
Thank you.